All right, we're going to start part two with the adjusting screw. This is a pretty good size. I want to do the outside because there is an allowance on the minor diameter of the Acme thread for the internal thread. So let's go ahead and get our geometry shape. The minor diameter will be the pitch. They've done it in sections, but this is a continuous thread through that length. So let's kind of figure out what they're doing here. 0.5 to the bottom of the slot and 1/2 inch wide by 1/2 inch keyway. All right, so 1/2 inch wide, 1/2 inch deep, and then that adjusting screw pin keeps it in alignment. So 0.25 to the bottom of the thread, looks like radius starting, that goes up into the bracket. So that being the case, let's go ahead and fix the bracket. All right, so I'm going to close my adjusting screw, pick up the bracket, and then another bilateral dimension. So we'll just open up the sketch on the bottom. "2" switch our tolerance to bilateral, and this was a +0 -1,000th. So it'll be interesting to see, because usually that would be a plus number. I want to see what they did on the stack up there. So features were extrude cut, and it can be through all or up to next. Let's go with up to next. All right, Control-7 for isometric, and Control-S for save. And then we'll open up our new part. All right, so kind of repositioning this for the adjusting screw. So this is a pretty good chunk of metal. It'll be interesting to see what this whole thing weighs. So new part, inch, will be in the front plane. And so drawing these, since most of these are vertical, I mean it fits on the page nice, but we're drawing them in the same orientation. The thing of note is that when I take this over into the assembly, I'm going to be doing a little bit of rotate to get it into to alignment with the rest of the assembly. All right, so we'll pick an edge, and pretty much just going to have to start somewhere. So the minor diameter at 2.5. Right, so when we look at the thread, we're going to see that the minor diameter is the major minus the pitch. So that's kind of where we're getting the 2.5 from. So it almost looks like that's going to come up. By the time it makes the cut, we're going to be pretty close to that edge. And then it's going to come out some distance. All right, so it's basically going to terminate at the minor, 2.5. And then our major diameter is 3 inch. So let's fly that back in real quick so I can explain where I'm getting those numbers. All right, so we're a 3-inch 2 Acme screw. So just like the rest of the threads, aside from the thread form, first number is the major diameter, the second number is the number of threads per inch. So 2 threads per inch means that from crest to crest is 1/2 inch, or from root to root is 1/2 inch. All right, so we're pretty much at that point. And we're going to have let's see, for the adjusting screw. All right, so that's inside of the nut. I wouldn't see any reason why it would need to go all the way to the end like that for alignment, but since it's writing up and down on the thread, that's intermittent. Okay, then yeah, pretty much we're going to go the entire length of the adjusting screw. So. Alright, so our dimension, we have a radius of 0.125, and that will set our depth. From L on the keyboard to get back into line, maybe. Alright, to the shaft. And wow, it really looks like they're going to press this in, and then that taper pin is going to lock it. So this would be 201 plus nothing minus 1. So at most, let's see the other side. Well, I'm going to have to look at that stack up because it was 2 inch minus 1 would put it at 199. And at the high end, the 201 would mean we'd have a 2000s press. So that's going to be a pretty heavy press. I'd almost want to say we need to, drill and ream for the number 8 pin in the assembly. That getting those to line up is going to be a challenge, especially if it's a casting. So we press it together and then we pin it. Alright, so back into our dimension, make sure that we are picking up the center line, and maximum material condition here will be the 2.01. We'll put in our bilateral, give it the minus 0.001. And then same thing, right click. Just off screen, we'll go mark for drawing, and then let's give it the overall length. Alright, so at this point I have not connected the dots, so to speak. Oh, that was the thread length, so we're not given an overall. So Control Z to undo. Pilot is 2.5625, so 2.562, 2 and 9/16, and then to that face. Sure is grabbing all my endpoints today, or midpoints. All right, 21.25. All right, so fairly good size piece. So now we know why they did one of those breaks. Alright, so that looks pretty good. We're going to tell it to revolve. Since I did not connect those, it's going to ask me, do I want to close the sketch? Yes, I do not want this to be a thin feature, so it can go ahead and complete. Alright, so we'll wait for the chamfer on the end, and in the meantime, I did a quick screen capture so I wouldn't have to go through the oops, I lost something there. Alright, apparently there's something else in that folder. Oh, those are my YouTube video lists. Interesting. Alright, let's see if it'll come back to the... So apparently I hit the scroll wheel. Crazy thing. Alright, here we go. Okay, so trapezoidal Acme thread has 29 degree, 14.5 half angle, and the pitch, from the pitch diameter, we have the 0.5 or 1/2 P, and then also at the pitch diameter is where we're getting the 0.5. So the crest and the root are a little bit shy of the 1/2 P. And then the allowance, there's a note. Let's see, as nominal And then the note that I was looking for is allowance is 20 thousandths of an inch for 10 or less threads per inch. All right, so we're doing 2, so that falls into the less than 10, and 10 thousandths for more than 10 threads per inch. So that gives us something to work from. All right, so picking this up, we're going to follow the same types of rules. We're going to need to have this go the entire length. So first of all, I need a helix, and I'm opening up the sketch. Just going to convert in the edge, and then go ahead and accept. That becomes my base circle, and as long as it's selected, when I go into the curve, I'm going to be able to find the helix and spiral. We do need to reverse the direction. It's going to be a clockwise thread. The pitch is 2 threads per inch, or 0.5. We're going to do height and pitch. So the height was around 21. So let's make it 22. So that runs completely off. When I go back to the front plane, it doesn't need to be. All right, so that almost terminates. That's right, it was 20.5 or 0.25. So that gives me enough to overrun it by at least half. All right, so I didn't quite pay attention. We need to figure out where that thread terminates. So seeing it over here. So that's going to put me in the top plane. And we'll open up the sketch. And the fun part about doing these on the graphics card challenge laptop is that it's going to try and rebuild on a regular basis. So let's reproduce the thread form, and then we'll figure out what we need it to do, where we're going to attach it at. All right, so there's my taper. All right, I do need a vertical to keep it in line, and then we'll make that for construction. We have a 29-degree included angle, and I'm going to make those symmetric. All right, and then the halfway point. All right, so well, pitch divided by 4 comes out to be half of the half. So let's just bring that over. I'm not quite sure I want that to be the midpoint. With it being at an angle, it should be off just a little bit. So horizontal. Probably should have made those symmetrical as well. All right, so the depth of 1/2 P is 1/4 of an inch. And so then from point to point, let's see, just double check the numbers here. Yeah, 0.5. So now in that case, I'll go ahead and bring that over. And horizontal. And so at the pitch, now we go 0.25. All right, so if I did all of that correct, then my numbers should work out to where that point can pierce, and we'll have half overhang. All right, so it we'll make one full thread. It won't leave any gap. And at the other end, it's guaranteed to at least go off of the part. All right, so the other interesting is that there should be enough on the crest then to also leave that flat. All right, so selecting and control selecting the helix, and then this is going to be a swept cut. If we see the preview, then there's a pretty good chance it's going to work. And then we'll go ahead and accept. All right, so the helix is still shown. I want to hide that so it doesn't have to recalculate it every time. Maybe. All right, so we'll hide the helix. All right, so we still have a fairly complex shape there, but it gives us something to work back from. All right, so then the next one will be from the front plane out. And I guess we're going to have to go tangent to the helix. I didn't really want to put in the slot first, but it might have been better. All right, so letting it calculate. Picking the outside edge. Creating a plane, so we're parallel to the front at tangent to the face. And then I'm opening up a sketch. And then we'll put in the ob round. And I think I want the ob round to start up here. And so we can put in a few dimensions without it trying to select something on the helix. All right, so the 0.5 from 0.5 is from the end, and then it's 10.75 long. All right, so we'll go, and that is given as an overall, so we need to go from arc to arc. I hope that didn't grab midpoint. Find out here in a second. All right, so max condition, if it grabbed the midpoint, probably wouldn't have given me that. Max in conditions, so 10.75 and 0.5 to the end. All right, so from my end geometry, and then I'm going to hold down the shift button and select the arc so it goes to that min condition, and then 0.5. And then now the last will be to pick the origin, pick the center line of the ob round, and that will be coincident. All right, and then feature, extrude cut, and we're going blind in condition to 0.5. So that's going to make a really interesting cut. All right, so we have about halfway on the screw, and then let's see. It probably doesn't have to be clocked that way exactly. Well, actually, it does. For that pin to ride up and act as an anti-rotation, then the taper pin. But the taper pin's being put in at the side. Let's go ahead and generate it. So let's see, right plane, nope. Well, on location, nope. All right, so we will do that as an assembly item. So I'm going to go ahead and put in the chamfer. 0.062, and really chamfers shouldn't be over 2 decimal places. They're not going to be anything that's going to be a tolerance dimension anyway. So if you want to You know, with it being 1/16 as a conversion, I can kind of get that, but all right, so this is the item 5. Support adjusting screw. All right, so the adjusting screw nut then is going to have that 10/1000ths of clearance. So we're going to move the pitch from this inside of 2-inch. We'll go to 2-inch and 20/1000ths as the opening, and then for the clearance, we'll stay with the for the fit, because the thrust bearing is going to slide over this edge and then act as the support at base. All right, so another inch front plane, and we'll sketch. All right, so if we move that over correct, then I'm thinking that that takes care of the allowance and the nut. So center line, vertical, infinite length. We'll go back into the line, up over. They put a couple of 16th chamfers. I'll go ahead and include those. All right, back to the center, and done. All right, so my allowance goes to 2-inch and 20/1000ths. The outside is 6 inches. Our critical dimension then is the 3748. So on an OD, that'll be the maximum material condition. We're going to go ahead and set this as a bilateral and minus 0.03. So max clearance, if I did that correctly, is about 5/1000ths. Overall height is 2.75. All right, and then those were perpendicular, so we'll get the 45 degrees in there. Need to set those equal, 0.062. All right, perpendicular and equal, we'll set the angle, and then 1.5 inches on the height. All right, that gives me my geometry. So features, Revolve boss base, 360 degrees. I'm going to start at the, actually we'll start at this edge. Oh, I need to create my helix first. So sketch, pick the edge, convert the entities, accept the sketch, go into the curve, set the helix. Certainly doesn't need to be 21 inches. This was 2.75, so height of 3 should cover it. All right, so that gives me my shape, and it's starting on the front plane. All right, so where the curve is coming down and terminating. Actually, I think I closed, so let's open up the support, adjusting screw. We'll identify that cut sweep and sketch 3. And even if I have to manipulate it a little bit, it already has all the dimensions in it. So after it gets through calculating, I might have been able to draw it by then. All right, I was going to try and Control C, but it's already all right, we'll see if that works anyway. All right, so on the front plane, we did a Control C, going to do a Control V. It came in. Edit the sketch. Well, We got most of it, so going to window pick, and under the editing, I'm going to rotate the entities. Let's make the center of rotation at the center of the geometry, and we'll look at it as 90. That looks like it'll work pretty good. Alright, so the advantage of picking the sketch over entering the sketch and getting the sketch geometry is that the dimensions come with it. Oh, and actually, that's going to be the wrong way. Alright, so now that we've determined direction, we'll go into rotate one more time. Center of rotation, and we're going to go 180. That looks better. Alright, so I need that point to pierce my curve, and I want to be a little closer to the solution. Yeah, we did lose some relations after all. No? Might have lost a dimension or two. Alright, so Control Z. Have the depth in the 0.25. And well, let's go ahead and go vertical. Alright, so that's what we're missing is some of those relations. Keep it from inverting on itself. So we're going to fit that to the current sketch. Alright, so now when I drag, alright, it's moving okay. We'll get it closer to the solution. And then picking on the curve, not on the endpoint, we'll make that a pierce. Alright, go ahead and accept the helix and the sketch. Select Control Select. And then this is going to be the revolved cut. Nope, the swept cut. There we go. It's like, wait a minute. There we go. Alright, so cuts through, we hide the helix, and we have the geometry. Alright, so pretty aggressive cut coming out of there, but that will work. So let's go with the front plane, and I'm control selecting the cylinder. And to reference geometry for the plane, they show the drill points for this. We want parallel to the face tangent. And then with that still selected, plane 1, I'm hitting S on the keyboard. Going in, I'm not rotating into the sketch, so 0.75, this is going to be at the midpoint. We're going to put in, and we were given a size, 0.749. So the 1.125 to the shoulder, I still think this is going to be easier. And with the round stock, yeah, I still think that's going to need a little bit of adjustment. And the other option would be to call out a weld. All right, so as long as we're doing 1040 to 1040 steel to 1040 or 1040 to 1020 wouldn't think it'd be that much of a difference, but maybe. 1.125 for the depth. And no countersinks. And then the position, we're going to set for the center line. So kind of the downside of setting the chamfer in the sketch is then I have to kind of react to it. Alright, so I'm through with the plane. I think I want to hide that. Maybe. Again. Alright, so let's go find it in the list. It's not going to let me hide. Alright, if I can't hide it, Then I'm going to stretch it because it's just the right size to be over top, and I do want that to be coincident. Alright, and then apparently it inferred the coincidence with the origin and vertical when I set it, so that's fine. And then I can go back into the point, and the point will set the location for the hole. Alright, so now I can right click on plane 1 and hide. And then the 3/4 inch, we'll pick up the circular pattern. The direction is around the cylinder. We're going to have 4 total. And we'll go ahead and accept. Okay, I think I have all of the geometry in there. So save, and item 3, the adjusting screw nut. Alright, so we could have built one piece and brought it in, and then built the next piece and brought it in, and then built the next piece and brought it into the assembly. So as it is, let's see, they're giving it a quantity of 1 for the finish hex jam nut, so apparently, yeah, okay, kind of see the, move it over a little bit, we can kind of see the nut on the outside there, so kind of wondering where that was going to come in. Alright, ready for the assembly. I think I have at least all the major components, and the rest we can find in the toolbox. So set for the assembly. I don't have the number 1 piece, so we're going to browse and open. Okay. And then by going to the checkbox, we're putting origin to origin. And just notice something else that I overlooked on this one was the fillets. So let's go ahead and accept. And I want to make a quick correction. So let's see, we had the 3/8 fillet around the outside, 1/8 inch fillets kind of everywhere else, or at least assumed to be typical. Alright, so I'll do those two first, and we'll see how they blend. So anytime I'm in one module and I need to jump to another module, right-clicking on that part and telling it to open will usually get me there the fastest. Okay, so there's the 3/8. And if I go to the base, and then to fillet, and those are to the outside and up and into the interiors. So those become 125, 1/8 of an inch. So in this case, the advantage of the face is that it's going to find all of those connecting items. What it doesn't find then is the verticals. And we'll go into the fillet, and I'll pick another face or another edge, and then we'll go along. And kind of hard to tell, but I think it goes to the outside. No, that doesn't, way too much. That's at least on that one. I think that's the one I want. Okay, that'll come around. And a little close there. And rotating over. Alright. So let's see if it finds its way around. Alright, so nothing jumps out as being a major miss. And we'll go one more. And save. Oh, and it went right into the assembly. So this is going to be 13.49. Let's get the actual name. The stock bracket. And save. Alright, so we'll close that one. When we... Oh, I did that out of the assembly. Well, hopefully I didn't make those assembly features. So let's double check. Oh, I sure did. Alright, so the difference here is that by putting the fillets in at the assembly level, they did not migrate. So when it didn't open, I missed. So those fillets don't do me any good, or aren't really helping anything, so we need to delete them. List all. Alright, we'll try again. And make sure that it opens this time. Alright, so stock base, I see the part symbol. That's looking a little bit better. Well, come on, do it to me. Okay. Don't feel too bad about that strategy, so we'll stay with the faces. And would actually try the upper face, except it's not called out in that direction. See if we can make a better selection on. So that looks pretty good. I'll take that one. Don't think there was anything on the bottom, so we'll go with those and then rotate over. Actually, I think that was a pretty good selection. Okay. Okay, and save. Now, I go ahead and so kind of my first indication that I did something wrong was that when I hit save, it saved to the assembly, and then going back to the assembly, thinking I had closed the part, I saw all of those fillets in place. Now there's no fillet features in, and so let's go ahead and start bringing in some of our geometry. So the one, the thrust bearing. All right, so the thrust bearing then would probably be a good one to bring in next and go ahead and just complete the stack up. So that gets saved. All right, so I did not find one of those in the that we can order. I did find that we could order the 440C chrome stainless steel balls. So this is going to be a Revolve, at least partial, and we're going to have multi-body parts. So we'll see how far this gets. So we'll draw as much of it as we can and then build it out from there. All right, so vertical, infinite length, and then going to accept, switch over to horizontal, place it, get out of it, and select. All right, so I'm going to draw on one side. We have the angle, step, comes back up to another angle, over, and then I'll make those collinear. Alright, so just kind of a rough sketch for the geometry. Alright, so the inside was 0.125 by 45. And the outside was 0.25 by 45. Oh, and it either picked up a perpendicular, perpendicular back to the other face. Alright, the outside dimensions, inside dimensions, need 1. And that would be 575. And the inside dimension is our 3.75. So with 3 thousandths on the minus 3,748 minus 3. Oh, well, it can grow a little bit bigger then. It's not too bad. All right, and then our overall 1.375. All right. The outside shape then is going to follow this contour. Let's see, 4.75 to the center. So that should be where the ball bearing rests, and it's 0.625. And 0.475. Or 4.75. There we go. Too many decimals. Alright, so not really given a gap. We do know that it's going to sit somewhere. But looks like we are given an overall height. So let's go to the 7/16. 437. Alright, so that looks pretty good. I can then right click, select chain. That should get me all the way around. Select my center line to mirror to. Alright, so that gives me an upper and a lower. And then constructing that outside retainer geometry, just kind of to the outside, 1 1/8 and to 5/875. And that's following the line around. Alright, so I want to call that, it's going to be a flat. It's an interesting piece. I'm not sure I would manufacture it that way. But since that's what we're given, we'll go ahead and select Control Select, pick up Symmetry. And then that way I can put in the overall height. It was 1.125. And then the outside diameter, 5.875. Alright, do want to stay parallel to the geometry. It's not really called out. So just kind of at a guess. Well, the other thing would be to stay consistent. I would think to stay consistent on the wall. So if I were to do something like a center line that comes off perpendicular, and then another one that comes off perpendicular, and make those two center lines equal, that would give me a consistent thickness. Alright, and then another symmetric, so select, Control, Select. Nope, I did parallel, I needed symmetric. Alright, symmetric, nope. So didn't like something in that mix. How about an equal? Alright, so didn't much care for symmetry. Might have been able to make one of the endpoints symmetric. That's okay. And then we'll close off that region so that we can have these as the separate bodies. Alright, so feature, we're going to do revolve. The axis of revolution is the center, and the two selected contours are going to be the top and bottom race. Go ahead and select. I'm going to reuse. Sketch 1, revolve. And I guess I could have done these as all of them without the merged bodies, but this kind of makes it a little clearer as to what's going on. Right, so I can hit the tab button and hide. Right, so one more, let's show the sketch this time. And I'm opening up a new sketch on the front plane. Alright, so convert. Go through the quadrants. Nope, still didn't convert it. There we go. At the center point, make that coincident. We can trim off 1/2. I'm going to select the region anyway, but features and set that as a revolve. No, we're not merging the result. The axis of revolution creates the sphere. Alright, so advantage here is since this is a single piece, I can go back and hide the sketch now. Since this is a single piece part number, if we need to create a multiple drawing and make this part, then we have that ability to extract this information as a multi-body or a master model. All right, so I'm looking for the sphere. And then we're going to circular pattern. I'm not sure that I wanted that face particularly, so clear the selection. I think I want one of the vertical. Alright, so like that one, not sure how many. Because we're dealing with bodies, we need to come down and check. And then pick. Alright, so no, it's not going to be 40, but it might end up being 16. Alright, might be able to get 18. And that might be pretty close. Let's go ahead and accept it and see what it looks like. No, there's still some pretty good gaps in there. Let's go to double click and I'll rotate around a little bit. And if I zoom in, there's the 18. So let's go up to 20. So I would think that it would be an even number, but 20 might max it, so. And rebuild. Alright, I think 22 is it. And get any closer, they're going to start overlapping each other. So we go back into the bodies, we show Revolve 2. And then that creates the bearing. Alright, so do I need that level of detail? Probably not, but since there's a mix of purchase parts and something that I might have to make, I do want to at least document that out to where even if I need to send it to a manufacturer and say, hey, do you have one of these that I can purchase off the shelf? Alright, item 8, the thrust bearing. Alright, so with the windows open, we're back into the assembly. Let's go with the File Explorer from within SolidWorks. We're going to see the items that are open. Now in the previous, I did not get a chance or didn't make a mate reference, so I'm going to go ahead with Concentric, and then the top face, and the bottom face, and those become coincident. And that is interesting that that 1/8 of an inch, we're going to have to look at that in section view. It's almost like that that angle, that chamfer is sitting down on the body of the part. I'm not sure if that was intentional, but that's an awful lot of load to be putting on a point and not have it roll over if that's the case. So time for me to check my dimensions and make sure I didn't miss something. But 4.75 to the center, 3.75. And then with the angle about 4 inches, maybe not. Alright, so let's go ahead and double check it by going into the section. Alright, so, oh, I got coincident to the wrong one. That's why I'm seeing it. Alright, so good time to catch that. Don't need to see all the bodies. I do want to see the mates. Alright, so the coincident. We're going to edit that feature. I'm going to take out item 8 of thrust bearing. And then we reselect the face. Alright, it moves up a little bit. Once I see it move up a little bit, then I'm feeling a lot more comfortable that I made a better selection. Alright, so I can close the thrust bearing. I want to take a look at the adjusting nut. And for the adjusting nut, that was left sharp, and that's an inside, so okay with that. I'm going to select that inside edge. And under reference geometry, we have mate references. I'm going to leave the edge and default and any. And then we'll go ahead and save. Let's see, the adjusting screw. I'm going to go ahead and close that one as well so that I can tile these vertically. And then if I drag from cylinder to cylinder, I'm going to get a concentric mate. If I import or insert this, then that mate reference comes into play as part of the geometry. So let's go to a standard component, existing, and that is the only one that's open. I drag along that edge, it snaps to the mate, and we go ahead and make sure that it did that correctly. Alright, so it's on the top. This is able to spin, and actually I think the adjusting screw is able to, or the thrust bearing is able to spin as well. So that concentric, I need to right click, and it's going through and doing the catch up, and we're going to lock the rotation so that it stays stationary. Okay, so that's looking pretty good. Before I get too complicated with all of the other geometry, then I'm going to go into the toolbox. So if the toolbox isn't active, it will come down and say, do you want to add it in? You say yes, add it in. And then I already went to the taper pin to make sure that it was there. We're calling this just plain cold rolled steel, so I'm going to go dowel pin unhardened and drag it to the hole location. It says there's no matching size. And it only goes up to 3/8, so I might have to draw that pin after all. Alright, so we'll double check just real quick. So on dowel pins, spring pin, slotted, and straight pin. Don't know if we're going to get something that large, but nope, still 3/8 of an inch. Alright, so after the fact, we'll go back in, this time back to the assembly. So insert components is the same as coming up to insert, which is the same as from the File Explorer, which is the same as dragging in from Windows Explorer. Alright, so we're going to pick up the support adjusting screw. I don't really want to get involved in all of those threads, so I'm going to make the two items concentric, and it shot it way down there and of course flipped it upside down on me. So not exactly a surprise there. And so on the concentric, we're going to flip the mate alignment. It throws it a little ways up, but I can at least bring it back to. And no, I did not want to add anything there. I just wanted to drag it in location, so I'm not sure what I hit to get that one, but make it match. Alright, so the intent is that we'll have then the adjusting screw guide. Alright, so what we haven't done is the windows. So let's see if I have my selections close enough. Alright, so if I just drag windows over here, and we have item 6, the adjusting screw, I can drag directly from and to. Alright, I didn't put a mate reference on this, so not really that big of a deal. We'll go cylinder to cylinder, and that becomes concentric. And since it probably moved it straight down, come back this way. And still not sure why it's popping that one up. Alright, so somewhere I should be able to find that oblong slot. And I'm going to try and rotate to where I can see the bottom of the pin. And then those become coincident. So depending on how it rotates, that was an interesting solution. That was not quite what I was expecting, especially since the adjusting screw already had a concentric on it. Or maybe it doesn't. Alright, so let's split the mate alignment. So I thought I hit the OK there, but... Alright, so the face, and then concentric, and OK. That's still behaving a little weird, but I think we're OK. Alright, so if those are in contact, then I should be able to do the face, and we're going to go to the advanced mates, and I want to see how much that's able to travel. So under the mechanical mates, then this is the slot, and it has free range. Go ahead and accept, and I'll look at it from the front. Alright, so it moves up and down and comes to a stop, and actually just a little bit past. So that may be where the contact. So it'll stop a little bit shy when it contacts onto the bracket. Alright, so that's pretty wild. Alright, so the adjusting screw then really doesn't matter. I mean, it's not going to move in and out. We've put it at contact. We've checked for clearances. So this is another one that doesn't really matter where it is in the alignment. I'm going to right click and lock the rotation, and that causes it to go fully defined without doing anything too strange. The other mechanical mate that we could do is, let's stay with the cylinders, and under the mate, then we'll go to the screw mate, and distance per revolution or revolutions per inch. We have 2 revolutions per inch, and we'll go ahead and add that. So whenever I turn this, it's going to move and drive it up and down within the consistency of the mates. And I still don't know what I'm selecting there that I'm getting that to bounce out. So let's make sure I'm not undoing something. No, the slot. No, it did. It lost the screw mate. So pretty much the 2 cylindrical. Alright, so hopefully on yours it is staying, once it's applied, it is staying put. And I'm going to save it just to be on the safe side and double check. So I'm going to go really fast and grab that again. So I'm not sure why it's coming back with those. So it's either trying to mate edit an existing mate or adjust it. Alright, so we're getting close. We need to do the bracket and the taper pins, a couple pins, and we'll wrap this one up. Alright, so the insert component, we'll go back and grab our double check, number 2, the support. Alright, and the intent here is that those will stay in alignment. So, okay, I really want to know what I'm picking here that keeps coming up. Alright, so we'll go back and make those 2 coincident. Alright, and then I would like to keep this parallel. Alright, so since there is that little bit of a gap, I don't know that that was the best possible coincident. It doesn't, yeah, it could be sticking up just a little bit. Yeah, pretty much it's going to drive. If we put it in shear, I'd really like to have those in contact. I don't think I'm so concerned with that. So we do want to stay parallel, and then we're going to add the assembly feature of completing out the tapered pin. All right, so on the drawing for this one, we would note drill and assembly, and on the other one, then we're going to align those geometries with it. So with the existing. So the right plane is of the part is pretty good. To the right plane of the assembly, I could make those coincident, but parallel is one of those. Again, I don't use it that much. So where it does show up, it's kind of something that will catch your eye. All right. So for the assembly, then we're going to create our first external reference. I'm going to right-click and edit the part, and I am in the assembly. So Control 3. And we're opening up a sketch on maybe not the right plane. Top plane? Nope. Should still be the front plane. Alright, so open up that sketch. And then when we go find the tapered pin, okay, so from there to there, see if we can find the midpoint. I can also turn on the temporary axes, which there's bound to be a few. Okay, all the way to the other side. Alright, see if we can pick up coincidence, line, close it. Alright, and then go ahead and accept. Alright, so I want to insert an assembly feature. Oh, wait a minute. This is an external reference, so we're just going to go right in and cut. So we have all of the tools just like we're in the sketch, even though everything else is transparent out. So Revolve cut. The axis of revolution is the line. All right, and even though it extends a little bit past, now we can hide our temporary axes, and we'll make sure to save. All right, so now when I open up the adjusting screw, that feature is going to have the dash greater than symbol, that it has an external reference back to that geometry, and all of the geometry in that sketch is tied to the taper and the bracket. Okay. So then the last piece is to insert, and we're going to bring in the roller. And we'll go concentric. And then I think as far as location, stay with the concentric. As far as our location, then the right plane. And we have to make a choice if we're going to do the right plane of the assembly and the right plane, and the right plane of the roller, or the right plane of the bracket. A lot of times I would go with the right plane of the bracket, so if this is able to rotate, this is able to rotate with it. And then mate and accept. Alright, so except for the pins, we're in pretty good shape. So my microphone cut out on me and had to charge it up, so I hope I didn't lose too much of the sound there. Alright, so we're going to insert the taper pin by dragging and dropping it to the hole. It says there are no matching sizes, so we need to identify. And there is the number 8, and the length is 4 inches. So that should get us to the taper pin. And no, I don't want to insert another one. We'll see what it has for size. So about 4.9, and we're in 2 decimal places. And just a little bit of the crown sticking out. So the radius ends that we saw. Alright, for the hex nut then, it's called out as a jam nut, hex jam. So we'll expand out the design library again. And we'll drag and drop. And hopefully that'll pop them out, maybe not. Alright, so I'm not sure what it grabbed onto for the... It didn't, so that's okay. We'll rotate over. Sometimes it'll find the coincident, and because we're going between the shaft and the boss, we'll go ahead and just apply. Alright, so that gives us our geometry. Going back through the items mentioned earlier, to be interested to know what the weight is. So we're going to say the taper pin and the hex jam nut, because it's not real easy to change our materials for the design library toolbox features. So those are going to remain unspecified. The support adjusting screw. We'll go to 1040. Well, would have sworn that I added 1040. Maybe it was the 41. Alright, so 1045. And thought we had 1040 in the mix. Alright, so we'll get something close, 1045. Alright, the stock. And the adjusting screw then was 1020. Alright, the thrust bearing we don't really have a mass on. We're going to pick, we'll pick a stainless steel. Bearing most of the material will stay. So we'll see what we can find. For mass, 316 would probably do it. 304. And then the stock support base is cast iron. Alright, so we're going to collapse that, and well, there we go, iron. So let's just go gray cast iron, close. Alright, so what else did I miss? The adjusting screw. I thought I had that one as 1020, so edit the material. I'll go ahead and expand these out and make sure that I'm applying all of them. Alright, so the appearance is changing with the materials. And then the support roller bracket was just plain carbon steel. Well, steel, no real specifications. So, all right, and the stock roller, 1040. We have 1045 again, so that'll be close enough for our calculation. And that gives us the pin. So when we go to evaluate, then we're going to mass properties. And so 272.66 pounds. Yeah, it needs the lifting lugs because this is a pretty beefy piece that we're going to need a hoist to move this around conveniently. So, so there's our piece. If you would like to make the drawings are optional. Oh, I mentioned the section view again. Chances are the Acme screws are not going to line up perfect. I'm really not concerned about that. And let's see. So the overlap, alright, if I turn the piece in, I should be able to get the overlap closer, and there's another one of those weird setting a mate relation. Alright, so if we needed to, if it was something that I really wanted that section view to see the alignment, then we would go with identifying the mate and suppressing it. I don't want to delete it because I want to bring it back on. Right, but if I suppress it, then it won't drive. And then I can rotate. Yeah, it's going to be a little hard with the wireframe. Okay, so it looks like my allowance might have gone, well, I mean, from there to there. So that's just a lot of geometry. Alright, so the check will be, we went 3 inches. We were 3 inches on the outside. That doesn't look like it's got, now it's still the outside's got the engagement, so I didn't get it matched up, and it's always a little bit of a challenge to get the threads to engage perfectly, so we would tinker around with that and get a little closer, but we're going to call that good for now. Go on to the next one.